This lesson is on the balancing of redox reactions in acidic solutions and basic solutions. We will do acidic solutions first. You always write the separate reactions for the oxidation and half reactions first. You don't really need to decide which one is the oxidation half reaction, which one is the reduction half reaction first. They will identify themselves as you balance the half reactions. For each half reaction, then you need to balance all the elements except for hydrogen and oxygen. For example, if there's chlorine, you balance those first, or chromium, you balance those first before you do the hydrogen and the oxygen. Then you balance the oxygen by adding water molecules to whichever side has the fewer number of oxygen atoms. Then you balance the hydrogen by adding hydrogen ions to whichever one has the fewer hydrogen ions present. And then you have to balance the charge by adding electrons. You add the number of electrons to the side that is more positive based on how much more positive that side is. Once you balance each half reaction, then you have to balance the two half reactions with each other. So you have to multiply each by an integer to equalize the number of electrons being transferred. For example, if your oxidation half reaction loses 3 electrons and your reduction half reaction gains 2 electrons, then we'd have to multiply the oxidation half reaction by 2 and the reduction half reaction by 3, so that 6 electrons are lost, 6 electrons are gained. You are then going to add the two half reactions and cancel out identical species or just reduce. And then, of course, you need to check to make sure all elements and charges are balanced. So I'll run through one example of each of the two types, acidic and basic. So here we see we have a compound with sulfur and we have a compound with chromium, or one of each on either side. We know that the chromium must go with the other chromium, and the sulfur must go with the other sulfur. So one of those will end up being the oxidation half reaction, one will end up being the reduction half reaction. So let's balance the top one first. Here we have two chromiums, so our non-oxygen, non-hydrogen elements balance. In terms of oxygen, this side has 7 oxygen atoms, this side has 3 oxygen atoms, and so since the reactant side has 4 more than the product side, I must add 4 water molecules to the product side, so now I've got 7 oxygen atoms on both sides. Next is to balance the hydrogen. The product side has 8 hydrogen atoms or ions, and the reactant side has 0. So to balance that, I need to add 8 hydrogen atoms to both sides. Now my hydrogen atoms are balanced. Then I have to balance charges. The reactant side has a net charge of 0. The reactant side is a net charge of 6 positive. We have 8 positives here, 2 negatives there, and so the reactant side is 6 more positive than the product side, so I have to add 6 electrons to that side. Now both sides have a net charge of 0 and they balance in terms of charges. For the other reaction, and by the way, the top one turns out to be the reduction half reaction since electrons are being added. So this second one is the oxidation half reaction, the sulfur changing into the SO2. Sulfur's balance. To balance oxygens, I'm going to add 2 water molecules to this side. So now I've got 2 oxygens to balance those 2 oxygens. Then to balance the hydrogens, I've got 4 hydrogens here, so I have to add 4 hydrogens to the product side. And now to balance charges, my reactant side is 0. Right now the product side is 4 positive, so I have to add 4 electrons to the product side. Now my reactant side and product sides are neutral. Okay, next step is to equalize number of electrons lost and gained. The reduction half reaction is gaining 6 electrons. Product is losing 4, so in the oxidation half reaction, lowest common multiple between a 6 and a 4 is 12. So we're going to multiply the top reaction by 2, the oxidation half reaction by 3, and that will give me 12 electrons lost and 12 electrons gained. Adding the two half reactions together, we've got 2 Cr2O72 minus plus 3 sulfurs. In terms of the hydrogens, when I multiply the reduction reaction by 2, that's going to give me 16 hydrogens there. Multiplying the bottom by 3 is going to give me 12 hydrogens there. And so we have a net of 4 hydrogen ions on the reactant side. And that'll complete our reactant side. For waters, we've got 8 waters here and 6 waters here. So the waters will end up on the product side. We're going to have 2 Cr2O3 plus 3 SO2 plus the net 2 water molecules on the product side. Again, multiply this by 2 to give us 8 here, 6 here, gives us a net of 2 water molecules on the product side. Let's check and make sure this balances. We got to balance our chromiums, balance the oxygens, the sulfurs, the hydrogens, and the charges must also balance. So chromiums, we've got 4 chromiums on this side, 4 chromiums on this side, they balance. We've got 14 oxygens on this side, and 2 times 3 gives me 6, 3 times 2 gives me 6 more, and 2 more gives me 14 on this side. 3 sulfurs on that side, 3 sulfurs on this side, 4 hydrogens reactant side, 4 hydrogens product side. The product side, everything is neutral, no charges on any of these species. So the net charge is 0 on the product side. Reactant side, we've got 4 negatives and 4 positives. So net charge is 0, that balances. That is a balanced redox reaction. For basic solutions, we're going to do exactly as we did the acidic solution and get a final balanced reaction. But if we go back to our one we just did, here we see that there are hydrogen ions present. That is okay for an acidic solution, but you cannot have hydrogen ions in a basic solution. And so we're going to add the number of hydroxyl ions as the number of hydrogen ions that you found in that balanced one. So if this reaction was in a basic solution, I would have to add 4 hydroxyls to both sides to reduce or to neutralize those hydrogen ions, and then reduce would be the last step. When you add hydroxyl ions, hydrogen ions are going to form water. So you're going to form the water by combining those ions and then cancel out or reduce to get it to balance out. And again, last step is to check the reaction. So let's do a basic solution. So here we have hydrogen peroxide. That'll go with the oxygen, and the Cl2O7 will go with the ClO2 minus. For hydrogen peroxide, the oxygens balance to balance the hydrogens. And the charge, we are going to add 2 hydrogens, 2 electrons to the product side. So that is the balanced oxidation half reaction. Since the electrons are on the product side, that is oxidation. For the other one, here we have 2 chlorines, so I need to multiply this by 2 to equalize the number of chlorines. And here we have 7 oxygens, only 2 here, so I'm going to add 4 here, because 2 times 2 gives me 4, so I add 3 water molecules to this side. So now I've got 7 oxygens on both sides. To balance the hydrogens, I've got 6 hydrogens on this side, so I have to add 6 hydrogens on this side. And to balance charges, this side has a net charge of 2 minus with the 2 hypochlorite ions, or chloride ions, and that side is 6 positive, and so the difference is 8 positives, so I have to add 8 electrons to the reactant side. Equalized number of electrons lost and gained, I'll have to multiply the top one by 4 so that 8 electrons are lost to balance out the 8 electrons gained. Okay, at this point, we need to add the two half reactions together. So here we've got 4H2O2 plus Cl2O7. And in terms of hydrogen ions, we're going to have 8 hydrogen ions on the reactant side, only 6 on the product side. So hydrogen ions will end up on the product side. No waters on the reactant side. That'll then give us 4 oxygens plus 2 ClO2 minuses and 2 hydrogen ions and 3 water molecules. So this is a balanced half reaction as if it was acidic. And now, because we have hydrogen ions, we have to add the same number of hydroxyls as hydrogen ions to both sides. These 2 hydrogens and 2 hydroxyls will form 2 water molecules. And so since all the water's on the same side, we will add and not cancel. If they were on opposite sides, we'd have to cancel. So here we have a final balanced reaction of 4 molecules of hydrogen peroxide plus Cl2O7 plus 2OH minus. This will go to 4 oxygens plus 2 ClO2 minus plus 5 H2O. In terms of balancing, we can check this. Here we have 4, 6 hydrogens, or 10 hydrogens. 4 times 2 is 8, plus 2 is 10. That gives me 10 hydrogens there. We've got 2 chlorines, 2 chlorines, and we have 8, 15, 17 oxygens, 8, 12, 15 oxygens. So all the elements balance. The reactant side has a net charge of 2 minus, and the product side has a net charge of 2 minus. That is a balanced reaction. Thank you for watching.